Okay. Ok- Um, yes, good morning. Good morning to all. I am Kanaka Durga, and I am uh, now I will teach you. I will give a brief revision about your analog communication systems. Is my voice is audible? Yes. Um, okay. In this session, we'll have some introduction and we'll have some problems regarding this analog communication system. You all know what is the communication system. So the basic function is to transfer our information from source to destination. And when coming to our block diagram, this is what our block diagram is. Consists of information source, input, transducer, transmitter, channel, noise, receiver, and then output transducer. And here will the main function of our transmitter, where we'll do our modulation process in this transmitter. And after modulation we transmit through a channel, and after in the channel some noise is added. So the message will transmit through our channel, and that will be received at your receiver. And coming to different types of modulation, these are the different types of modulation: continuous wave modulation and then pulse modulation. So here in this continuous wave modulation, we'll have amplitude modulation, angle modulation. And the main difference between this continuous wave and pulse modulation, here the carrier signal is sinusoidal, whereas in case of your pulse modulation, here the carrier signal is pulse. So what is modulation? What is modulation means the basic function is to convert. You all know what the basic function here is to convert a low frequency signal into a high frequency signal. So basically our message signals which are of low frequency signals, for in order to transmit for longer distance, we need to convert into an convert these low frequency signals into a high frequency signals. So based on this, we are going to multiply our message signal is multiplied with your carrier signal. So it is of high frequency. So and we are going to vary the characteristics of these carrier signals. So for our modulation, so if you vary your amplitude, then it will become an amplitude modulation. By varying frequency of your carrier signal, frequency modulation. If you vary the phase, then it will become your phase modulation. So I will give just a brief regarding this. You all know what is how we are AM amplitude modulation. As I just now said, in this amplitude modulation, we are just going to vary the amplitude of your carrier signal in accordance with your message signal. So this is your message signal and carrier signal. So once if you modulate, so this is your amplitude modulated signal. So this is message signal, carrier signal, and then modulated signal. So, so your modulated signal will be like this. So when comes to the modulating signal, we can represent in time domain representation as m of t equal to am cos of 2 pi fmt, and c of t will take our carrier signal is ac cos of 2 pi fct. So and the modulated signal your s of t for amplitude modulation is AC into 1 plus Ka m of t cos of 2 pi fct. So these expression is very important when comes to our gate. Okay. So in order to, they may generally ask the questions from this mod based upon this modulated signal. So your S of t equal to, just remember this, your S of t, the modulated signal S of t equal to AC into 1 plus Ka m of t cos of 2 pi fct, where AC is your amplitude of your carrier signal, where K is amplitude sensitivity, and m of t is your message signal, and Fc is carrier signal frequency. Okay, so this is a generalized expression. So and these can also be written as AC into AC cos of 2 pi fct plus AC K m of t cos of 2 pi fct. Here we can write the same expression as AC into 1 plus mu into cos of 2 pi fmt cos of 2 pi fct, where mu is your modulation index. So generally when it comes to our gate point of view, so they will ask based upon uh, your by giving your modulation index, and they may ask us to find the power. So or they will ask us to find out what is your modulation, what is the modulation index. So just mu modulation index mu equal to am by ac. Okay, this is what the expression. So from this generalized expression, your s of t equal to ac into 1 plus mu cos of 2 pi fmt cos of 2 pi fct, where mu equal to am by ac. So, and we can also write another expression for our mu equal to a max minus a minimum by a max plus a minimum. So what is this? A max is maximum amplitude minus minimum amplitude. So you can just get from this, this is your maximum amplitude and this is your minimum amplitude. Your maximum amplitude minus minimum amplitude by maximum amplitude plus minimum amplitude. So this is also another expression for our modulation index. I think you all know how to derive these expressions. Okay. So your mu modulation index can be given as a max minus a minimum by a max plus a minimum. So and based upon these mu, when mu is less than 1, so these mu will go under modulated signal. When mu is greater than 1, so this will become an over modulated signal, and we can observe the modulated signal will be like this. So when mu is greater than 1, your negative portion will shift towards negative. So we'll get an phase reversal here when your mu is less than 1. So in this case, it may also become for us to difficult for us to reconstruct our original signal. So next, you all know, in our amplitude modulation will consist of a carrier signal. So when we draw the spectrum, it consists of a carrier signal, your upper sideband and lower sideband. When we calculate the power, total power required for AM transmission, your power will be equal to PC plus PUSB plus PLSB. That is power required to transmit your carrier plus power required to transmit your USB plus power required to transmit your LSB. So generally, when comes to your gate point of view, they will ask us to find what is the total power required. What is the total power required? Or they may ask us what is the carrier power required, and what is the power, what is the sideband power required. So and they will ask in this way. So we'll see some of the problems here. You just observe here. So here they have given an AM signal. So in this AM signal, so one second. An AM signal is represented by x of t equal to 20 plus 4 sine 500 pi t cos of 2 pi into 10 power 5. So this is what the generalized expression s of t equal to. So they may ask you like this, and they will give an AM signal. Your AM signal is represented by x of t equal to 20 plus 4 sine 500 pi t cos of 2 pi 10 power 5. 10 power 5 into t, sorry. Okay, so now they just ask us to find out what is the modulation index. So what is the modulation index, and what is the total signal power, what is the total signal power required to transmit this AM signal, and what is your total sideband power. Okay, what is your total sideband power. So in order to find out this, so in order to solve this problem, first you just compare the given expression. So what is the AM signal they represented? Your AM signal x of t equal to 20 plus 4 sine 500 pi t cos of 2 pi into 10 power 5 into t. Uh, just compare this with your generalized expression. So you all know what is the generalized expression for AM signal. What is the generalized expression? Your s of t equal to AC into 1 plus mu m of t into cos of 2 pi fct. You just compare these. You just compare these with your generalized expression. With your generalized expression. So when we compare these, and we can write this expression. We can write these expression x of t can be written as, you just take 20 as common. You just take 20 as common. When we take 20 as common, we can write it as 20 into 1 plus zero point 0.2 sine of 500 pi t into cos of 2 pi 2 pi 10 power 5 into t, isn't it? So now you just compare these expression with our generalized expression. So when we compare these with your generalized expression, So if you compare here, what is the generalized expression? S of t equal to AC into 1 plus mu. 1 plus mu m of t cos of omega ct, isn't it? So now when we compare these with your generalized expression, we can write what is our modulation index. So from these, what is our modulation index? Your modulation index mu is nothing but 0.5, isn't it? AC into 1 plus mu, AC into 1 plus mu m of t cos of omega ct. When we compare, we can write our modulation index mu equal to zero point 0.2. So this is what the solution. So when they ask us to find what is a modulation index, so generally in our when we come to our analog communication system, so they will give an expression. So from that expression itself, first of all we should identify what is the modulation technique. So what is the modulation technique we are asking, well, we are using here. So sometimes they may even doesn't give these an AM signal. So generally they will give it as a signal. A signal is represented by this. In this way they will give. Okay, so by seeing the expression itself, we should identify, what is the modulation technique they are using. So for this, we should know all the generalized expressions. So you all know what is the basic difference, between your all the modulation techniques, isn't it? So in case of your amplitude modulation, so the generalized expression is AC into 1 plus mu m of t cos of omega ct, isn't it? So when we come to your DSBSC, how your expression will be nothing but a product of m of t into c of t. DSB is nothing but product of m of t into c of t. Similarly, when we come to your SSB, so what is your SSB? In this SSB will have only one single sideband, so either upper sideband or lower sideband. In case of your upper sideband, your expression is represented with minus. In case of lower sideband, the expression is represented with plus. So by seeing the expression itself, we should sometimes they may not directly give what is the type of modulation they are using. So by seeing the expression itself, we should identify what is the modulation technique they are using here. Okay, but anyhow in this problem they have clearly mentioned this is an AM signal. So we compare the given expression with our generalized expression. So when we compare, from that comparison we'll find what is your modulation index. So when we compare, we got a modulation index is zero point 0.2. Okay, so next, what is the next question they are asking? They are asking what is the total signal power. So what is the total signal power? So in order, you all know what is the total signal power. So what is the expression? So total signal power PT equal to PC into 1 plus mu square by 2. So I think you all can remember these. What is the total power expression? PT equal to PC into 1 plus mu square by 2, isn't it? So first, here, in order to find your total signal power, so PT represents your total signal power. PT equal to, so if we need to find what is your carrier power and what is the power required to transmit your sidebands. Okay, so what is the power required to transmit your PC carrier power? So your carrier power can be given as PC equal to, so a square, isn't it? A square by 2, AC square by 2. So what is your, when we compare with generalized expression, what is your AC here? AC is nothing but 20. So your PC will be equal to 20 square by 2. So what is your 20 square by 2? Nothing but 200 volts. So first we calculated our carrier power. So once we calculate our, we know our modulation index and we know our carrier power. So now you substitute these in your expression, that is total power. Your PT will be equal to PC into 1 plus 0.2 whole square by 2. So if you substitute here, so we'll get our total power which is equal to 204 volts. Our total power which is equal to, if you calculate this, you know our modulation index. What is your modulation index? Modulation index is 0.2. And what is your carrier power? Carrier power is 200. And if you substitute these in this expression, we'll get our total power is 204 volts, isn't it? So in this way we calculated our total power. The total signal power required to transmit these AM signal is 204 volts. Okay, so next, what is the next question they're asking? They're asking us to find out what is the total sideband power. So that means what is the sideband power required? What is the sideband power required? We know the total power, and we know our carrier power. So you all know what is actually the total power PT, which is equal to the power required to transmit your carrier signal plus the power required to transmit your sidebands, isn't it? So from there, if you need to want to find out what is your the power required for transmitting your sideband, so then we can write from that expression PSB equal to total power minus your carrier power. So if you write this, so nothing but 204 minus what is the carrier power? Nothing but 200. So 204 minus 200 is nothing but 4 volts. So in this way, we can find the modulation index. We can find the modulation index, the total signal power, the sideband power. So sometimes they may give in this way also. They will give an expression. So from the expression, they may ask us to find out what is the modulation index. So what is the total signal power required to transmit these AM signal, and what is the sideband. So what is the total sideband power required to transmit these AM signals. Simple problem, a very very simple problem. So the one thing is we should remember the generalized expression for these AM signal. So nothing but S of t equal to AC into 1 plus mu m of t cos of 2 pi cos of omega ct. So if you remember these expression, and when we compare these expression with our given expression, we can easily find what is the modulation index and what is your total signal power. So and what is your sideband power. So you just remember one thing, in your AM modulation, the total power required will be equal to the power required to transmit your carrier plus the power required to transmit your sidebands, that is your upper sideband and then your lower sideband. Your PT will be equal to PC into 1 plus mu square by 2. 1 plus mu square by 2. Okay, you all know how to derive all these expressions and all those things. So first we'll write in case of time domain, and then we'll draw our frequency domain. So then we'll find out our total power required. Okay, so then we'll find our total power PT will be equal to PC into 1 plus mu square by 2. So by using that expression, we can find this modulation index, total signal power, and then your sideband power what is required. Okay, so here also we have another example. AM signal has the form S of t equal to 20 plus 2 into cos of 3000 pi t plus 10 into cos of 6000 pi t. So into cos of 2 pi fct, where fc is 10 power 5 hertz. So they have given a modulation index, and they are asking us to find out the sideband power to the total power. So you just follow the same thing, and we can solve this problem also. You yourself just try this. Next, we'll go for another problem. Are you able to follow this? Okay. So we'll go with another problem. So in this, we are having a 2 kilowatts carrier. They are given a 2 kilowatts carrier is to be modulated to a 90% level. 90% level. So the total transmitted power would be, so when we transmit a 2 kilowatt carrier to be modulated, that means the power, the carrier power is nothing but 2000 kilowatts. Sorry, 2 kilowatts. Nothing but 2000 watts. So is to be modulated to a 90% level. So to be modulated to a 90% level means what is a modulation index? So what is a modulation index? Your mu will be equal to 90 by 100, which is nothing but 0.9. Your modulation index is 0.9. So from here, the total power would be, so what is the total power? What is the total power would be? So you all know what is total power. What is a generalized expression? PT will be equal to PC into 1 plus mu square by 2. You just substitute what is the carrier power. What is your carrier power is in the question they have given. A carrier of 2 kilowatts. So just substitute this 2000 into 1 plus what is the modulation? They are modulated to a 90% level. So from here we can find our modulation index. Nothing but 0.9. So 2000 into 1 plus 0.9 square by 2. So which is when we find. So these will be equal to 2810 watts, nothing but 2.81 kilowatts. So that means our answer is, correct answer is B, 2.81 kilowatts. So this is the total power required. This is the total power required. So next, the next problem, the aerial current of an AM transmitter is 18 amp. So the aerial current of an AM transmitter is 18 amp when unmodulated, but increases to 20 amps when modulated, isn't it? So the aerial current of an AM transmitter is 18 amp. That means this will become your carrier power current, isn't it? Carrier current. So and after modulation means that is your total current. So we all know from the power we can derive the expression for your current also. So from the power we can derive our expression for current. If you derive the expression, your total current IT will be equal to IC into square root of 1 plus mu square by 2, isn't it? So IT will be equal to IC into square root of 1 plus mu square by 2. So from the question they have given your IC and also they have given your IT. So and they just asked us to find out what is the modulation index. So what is the modulation index? So if we just simply some substitute here, we'll get our modulation index mu equal to 0.68, isn't it? Are you all able to follow? So you all know PT. So from the power, so what is the relation between your power and current? So power is directly proportional to I square R. So if you substitute in place of your power, if you write in terms of current, and if you derive the expression, and when we derive the expression, so these will be equal to IT will be equal to IC. IT will be equal to, you all know PT will be equal to PC into 1 plus mu square by 2. So from there you substitute your PT. PT will be equal to IT square into R equal to. So what is your PC? IC square R. So you just if you from there if you derive the expression for IT will be equal to IC into square root of 1 plus mu square by 2, isn't it? So in the question they have given before when unmodulated, the current is 18 amp, and after modulated the current is equal to 20 amp. This will become IT. So your IT is 20 amp and your IC is 18 amp. So 20 equal to 18 into square root of 1 plus mu square by 2. So now if you saw from here we can find our modulation index. So what is a modulation index? So your modulation index mu equal to 0.68. So even if they are given in terms of current or if they are given in terms of power, we can find our modulation index. The simple expression is PT equal to PC into 1 plus mu square by 2. So this is in terms of powers. If they give in terms of current, so current means your IT will be equal to IC into square root of 1 plus mu square by 2. So they may ask us similarly, they may ask us to find out the modulation index, or suppose they will give your modulation index also. They may ask us to find what is your carrier current, or they may ask us to find what is your total current, what is the total current required. Okay, so whatever may be the question, the we should remember, we first will compare with our generalized expression. So in that way they may ask us, or we by using power expression, your PT equal to PC into 1 plus mu square by 2. In terms of current, your IT will be equal to IC into square root of 1 plus mu square by 2. Okay, are you all able to follow? Next. So just see here, they are given another example. A 2 megahertz carrier a 2 megahertz carrier is amplitude modulated is amplitude modulated by a 500 hertz modulating signal to a depth of 70 percentage. To a depth of 70 percentage means what is your modulation index? Your modulation index mu, which will be equal to zero point 0.7, isn't it? Here your modulation index mu is zero point 0.7. And the question they have given the carrier power, the carrier frequency. What is the carrier frequency? Fc equal to 2 megahertz is amplitude modulated by a 500 hertz modulating signal. That means your frequency of your message signal, your FM will be equal to 500 hertz. If the unmodulated carrier power is 2 kilowatts, then the power of the modulated signal is, then the power of the modulated signal power is. So if you find out, we'll get it as 2.23 kilowatts. You can just try this in the similar way what you have done in the previous cases. So if you try it, we'll get an 2.23 kilowatts. You can just try this. So if you try this, we'll get a 2.23 kilowatts. Okay. Okay. You just try this. So in the next question, you just see here a carrier is a carrier is simultaneously modulated by two sine waves. We'll go with another example. A carrier is simultaneously modulated by two sine waves with modulation indices of zero point 0.4 and 0.3. So what is the resultant modulation index will be? So what is the resultant modulation index? So if you observe here, in the question they are given a carrier is simultaneously modulated by two sine waves. So when we are modulated by two sine waves, so these will become nothing but a multi-tone AM modulation. So in case of your single tone AM modulation, we'll have only one sine signal. We'll have only one sine signal. Whereas in case of these multi-tone, so we can have two sine waves. So two or more. When we have two or more sine waves, then we'll call it as a multi-tone amplitude modulation. So in the question they have given a carrier is simultaneously modulated by two sine waves with modulation indices of zero point 0.4 and zero point 0.3. So they are asking the resultant modulation index is. So what is your resultant modulation index? So nothing but we can calculate these as resultant modulation index, which is equal to, we can write it as uh, mu t, the total. So mu t square will be equal to mu1 square plus mu2 square, isn't it? Mu t square will be equal to mu1 square plus mu2 square. So that means nothing but zero point 0.3 whole square plus zero point 0.4 whole square. So which will be equal to 0.5 square. So from here, if you calculate what is resultant modulation index, mu equal to 0.5. So in this way also we have two sine signals, or we can have three sine signals or four sine signals, and they may ask us to find out what is the resultant modulation index. What is the resultant modulation index? The resultant modulation index, which can be given as mu t square. equal to mu1 square, mu2 square plus mu3 square. So on and on like this. This mu1 is modulation index of the first sine wave, mu2 is modulation index of second sine wave, third sine wave, fourth sine wave. So when then we'll get it as a multi-amplitude modulation. So in case of single tone, we'll have only one frequency. So when we come for this multi-tone, we'll have two or three. Okay, sometimes they will give the modulation indices of different sine waves, and they may ask us to find out what is a total resultant modulation index. So in order to find this, your mu t square will be equal to mu1 square plus mu2 square. So in the question, they have given 0.4 and 0.3. So if you substitute this 0.3 square plus 0.4 square, so which will be equal to 0.5 square. Simple problem. So from here, we can write our mu, the resultant modulation index, mu will be equal to 0.5. So this is a very simple problem. They may ask in one mark questions. They in gate they may ask these types of questions. So now we go with another example. So just you also try these also. A 10 kilowatts carrier is sinusoidally modulated by two carriers corresponding to a modulation index of 30% and 40% respectively. And they are asking to find out what is the total radiated power is. So what is the total radiated power? So if you observe here, they given two modulation index. Two modulation indexes means nothing but this is an multi-tone amplitude modulation, isn't it? So when we have two, so in the previous classes we have studied. You all know what is the generalized expression for total power. So total power PT will be equal to PC into 1 plus mu square by 2 when we have only one. So now here they have given we are using two carriers. So two carriers. So what are the modulation index? 30% and 40%. Nothing but mu1 will be equal to 0.3 and your mu2 is nothing but 0.4. So now how your expression changes, your PT will be equal to PC into 1 plus mu1 square by 2 plus mu2 square by 2. Isn't it? So in the previous case, what is the generalized expression? PT will be equal to PC into 1 plus mu square by 2. So there we are having only one modulation index. But here we are using two carriers with a modulation index of 30% and 40%. 30% means your mu1 will be equal to 30 by 100. What is your 30 by 100? Nothing but 0.3. And what is your mu2 is 40%. 40% means 40 by 100. 40 by 100 is nothing but 0.4. Your mu1 is 0.3 and your mu2 is 0.4, isn't it? So if you substitute here in the generalized expression, you all know what is the total radiated power. PT will be equal to PC into 1 plus mu1 square by 2 plus mu2 square by 2. So if you substitute there, and they have given a 10 kilowatt carrier, that is the carrier power PC will be equal to 10 kilowatt. So and if you substitute in our generalized in our total power, PT will be equal to PC. What is your PC is 10k. 10k into 1 plus mu1 square. Mu1 square. What is mu1 square? 30% means 0.3. So 0.3 square by 2 plus 0.4 square by 2. So and once if you calculate these, so these will be equal to 1125 kilowatt. So 1125 kilowatt. So you can try this. So 10k into 1 plus 0.3 square by 2 plus 0.4 square by 2. So if you calculate this, we'll get it as 1125 kilowatts. Sorry, 11.25 kilowatts. Here we have 0.25 kilowatts. Okay, here in this example, just they have given two carriers with a modulation indices of 30% and 40%. So from here, we'll find our mu1. Mu1 will be equal to 0.3 and mu2 is 0.4. You just substitute here. So you all know what is the total power. PT will be equal to PC into 1 plus mu square by 2. So in case of single tone, okay, single tone means we'll have only one carrier wave. In case of multi-tone, we'll get an expression as pt equal to pc into 1 plus mu 1 square by 2 plus mu 2 square by 2 plus, it's simple, mu 1 square by 2 plus mu 2 square by 2. Suppose if they have given 3 means how we'll get the expression pt will be equal to pc into 1 plus mu 1 square by 2 plus mu 2 square by 2 plus mu 3 square by 2, like this you will get it. And once you substitute there, and we can calculate our total radiated power. So if you calculate your total radiated power, so these will be equal to 11.25 kilowatts, 11.25 kilowatts. So in this way we can find our total radiated power. We can find our total radiated power. So are you able to follow this? A 10 kilowatt carrier in case of single tone, in case of multi-tone. So generally they will ask these type of questions only. In case of single tone, so they will ask you to find out what is the total power required, upper sideband power or lower sideband power. So they will ask us to find out the current, or they will ask us to find what is the resultant modulation index in case of multi-tone, if you are using multi-tone AM modulation. So like these only, they will ask us the questions. Okay, we'll go with another example. So we'll go with another example. You just see here, an AM signal is detected using an envelope detector. You just clearly observe here, an AM signal is detected using an envelope detector. You all know what is an envelope detector is. So these envelope detector, which is one of the technique which we use to demodulate our AM signal at our receiver. So in the receiver, we are going to make use of these envelope detector. So what does this envelope detector consist of? We'll have a diode and then resistor and then capacitor, isn't it? So this envelope detector is a circuit which we use to demodulate our original signal, which we use to demodulate our original message signal. So the carrier frequency and modulated signal frequency are 1 megahertz. So what is the 1 megahertz and 2 kilohertz respectively? And they are giving us the carrier frequency. So what is the carrier frequency? Our carrier frequency is 1 megahertz. And modulating signal frequency, and they are given our modulating signal frequency means FM. Your FM is nothing but 2 kilohertz. So they have given FC 1 megahertz. Our FM is 2 kilohertz. They are asking an appropriate value of the time constant of the envelope detector is. So now we need to find out what is the time constant, approximate value for the time constant of the envelope detector. So they have given the options 500 microseconds or 20 microseconds or zero point 0.2 microseconds or 1 microseconds. Okay. So you all know. So what is the expression? What is the expression for this time constant? So this time constant, nothing but RC. So these should be in the range of 1 by Fc less than or equal to Rc less than or equal to 1 by 2 Fm. So this is we'll get this, we'll find, we have a derivation for this, and once if you derive that expression, so we'll get our range, our time constant will be in the range of 1 by, should be in the range of 1 by Fc, should be less than or equal to Rc less than or equal to 1 by 2 Fm. So these we should remember these expression 1 by less than or equal to RC less than or equal to 1 by 2 FM. Okay, so in the question they have given what is your carrier signal frequency. So what is your carrier signal frequency? Carrier signal frequency is 1 megahertz, isn't it? Your modulating signal frequency. Modulating signal frequency is 2 kilohertz. Your modulating signal frequency is 2 kilohertz. That is your FM is 2 kilohertz. So from this, if you find out your FC will be equal to 1 megahertz and your 2 FM. So 2 FM is nothing. What is this 2 FM? 2 FM is nothing but bandwidth. Bandwidth required for our AM signal. So you all know what is the bandwidth required for AM signal. So once if you draw your frequency spectrum, so we'll get a where we and all we are having the spectrum FC. So FC carrier, and we'll have our upper side band FC plus FM, and your lower side band is FC minus FM. So once if you find the bandwidth, so what is the bandwidth required for AM? Nothing but 2 FM, isn't it? FC plus FM minus FC plus FM. So if you subtract upper frequency minus lower frequency, once if you subtract there, and if you find out what is the bandwidth required for your AM, the bandwidth required for AM is nothing but 2 FM. So the generalized bandwidth will equal to 2 FM. You all know what is your message signal frequency. Message signal frequency is 4 FM. So if you substitute these in our expression 1 by FC less than or equal to RC less than or equal to 1 by 2 FM. So if you substitute here, so nothing but 1 by 10 power 6, isn't it? What is this FC? FC is 1 megahertz. 1 mega nothing but 10 power 6. 1 by 10 power 6 less than or equal to RC less than or equal to 1 by 2 FM. What is 2 FM? 2 FM is nothing but 4 kilohertz. So 4 into 10 cube. 4 into 10 cube. So once if you solve this, 1 by 10 power 6, 1 by 10 power 6 is equal to RC less than or equal to 1 by 4 is nothing but 250 micro. So that means 1 10 power minus 6, isn't it? We can write 1 by 10 power 6 can be written as 10 power minus 6 less than or equal to RC less than or equal to 250 micro. So if you substitute these, the approximate value, what is that approximate value for the time constant is nothing but 20 microseconds. So in this way, we'll find our approximate time constant of the envelope detector. Time constant but RC. Your RC can be approximately 20 microseconds. So the one thing is we should remember this 1 by FC should be less than or equal to RC less than or equal to 1 by 2 FM. What is this 2 FM? 2 FM is nothing but bandwidth. So sometimes they may directly instead of this modulating signal frequency, they also give bandwidth. So there is a bandwidth. So they may give in this way. So giving the modulating signal frequency FM, directly they may give bandwidth. So the thing. Just remember, the bandwidth is equal to 2 FM. The bandwidth required for AM signal is 2 FM. So 1 by FC less than or equal to RC less than or equal to 1 by bandwidth. So from there we can find our time constant. Is it? So here we go with another example. An AM voltage signal, S of t, an AM voltage signal S of t with a carrier frequency of 1.15 gigahertz. 1.15 gigahertz has a complex envelope G of t equal to AC into 1 plus M of t, where AC equal to 500 volts, and that is amplitude of your AC amplitude is 500 volts, and the modulation is a 1 kilohertz sinusoidal test tone described by M of t equal to 0.8 sine of 2 pi into 10 cube t appears across a 50 ohms, appears across a 50 ohm resistive load. So what is the actual power dissipated in the load? What is the actual power dissipated in the load? Okay. So that means what is the actual power dissipated in the load means we need to find out our total power. So what is the total power required? PT. So PT we need to find. So you all know what is your PT. PT equal to PC into 1 plus mu square by 2. Isn't it? PT equal to 1 plus mu square by 2. So if you observe here, just the question may be bigger here. Okay. So just not to confuse us, they will give a question like this. Okay. But here the thing is we need to find, just simply we need to find our PT only. So you all know what is your total power. PT equal to PC into 1 plus mu square by 2. 1 plus mu square by 2. So this is what the generalized expression g of t equal to AC. So just observe here, an AM voltage signal S of t with a carrier frequency of 1.15 gigahertz has a complex envelope g of t equal to AC into 1 plus m of t. So if you substitute, they have given this m of t equal to 0.8 sine of 2 pi into 10 cube t. So if you substitute these here, this is what your generalized expression. This is in the form of AC into 1 plus mu m of t, isn't it? So uh, 0.8. So that means from these we can write our modulation index. Modulation index is zero point 0.8. So from here we can get our modulation index is zero point 0.8. So and they have given your AC equal to 500 volts. So from here we can find our carrier power, isn't it? So what is your carrier power? PC will be equal to AC square by 2. So PC will be equal to AC square by 2. So what is your AC is 500 volts. That is 500 square by 2. So from there you first find out your carrier power. So first you find out your carrier power. So what is your carrier power? PC will be equal to AC square by 2. So once if you find your carrier power, so PC, and you know what is your modulation index is? Modulation index is zero point 0.8. And if you substitute in our general expression, total power PT will be equal to PC into 1 plus mu square by 2. So if you substitute there, and once if you calculate, the total power required PT will be equal to 165 kilovolts. So total power will be equal to 165 kilovolts. So just in order to confuse us, they have given the question in this way. Okay, nothing here. They are given the carrier frequency. So okay, and the question they have given the voltage of your carrier signal, voltage AC. So once if we know the voltage, we can find our carrier power, isn't it? Carrier power PC will be equal to AC square by 2. So and given m of t equal to 0.8. So from there we can find our modulation index. So once if you know all these things, we can find our total power PT will be equal to PC into 1 plus mu square by 2. So from there, if you find the total power, the actual power dissipated in the load, that is PT will be equal to 165 kilowatt. The actual power dissipated in the load, nothing but the total power. The total power. So the total power PT will be equal to PC into 1 plus mu square by 2. Is that clear? So next we'll go with another problem. So sometimes they will ask us the questions based upon in this way also. For an AM signal, the bandwidth is 10 kilohertz. The bandwidth is 10 kilohertz. Just now I said, what is the bandwidth required for AM signal? What is the bandwidth required for AM signal? In order to transmit your AM signal, the bandwidth required is 2FM. So in the question they have given the bandwidth is 10 kilohertz and the highest frequency component present is 705 kilohertz. So you all know what and all the frequency components that is present in our AM signal, isn't it? So what and all the frequency components that are now present? Your carrier signal frequency power, sorry, your carrier frequency, that is FC, and the upper sideband frequency. What is the upper sideband frequency? FC plus FM. And what is the lower sideband frequency? FC minus FM. Okay, among these, what is the highest frequency component? So when they give the highest frequency component, what is the highest frequency component? Nothing but FC plus FM, isn't it? The highest frequency component is FC plus FM. So from the question, so you just clearly understand this question. For an AM signal, the bandwidth is 10 kilohertz. So that means your bandwidth is 10 kilohertz. That is your 2FM band. You all know what is the bandwidth required for AM. The bandwidth is 2FM. So your 2FM is 10 kilohertz. So from there we can find our what is the message signal frequency. What is the message signal frequency? Your FM will be equal to 5 kilohertz. Okay. So next to what they have given, and the highest frequency component frequency present is 705 kilohertz. The highest frequency component present is 705 kilohertz. That is highest frequency component, nothing but FC plus FM. So your FC plus FM is 705 kilohertz. And we got our FM. So they are asking what is the carrier frequency used for this AM signal. That means we need to find out what is your FCs. They have given your bandwidth. Bandwidth is 2FM. So 2FM, from there, once if you calculate your FM, so your FM will be equal to 5 kilohertz, isn't it? So and they have given your highest frequency component. What is the highest frequency component? FC plus FM. FC plus FM is 705 kilohertz. Okay. So we know this FM, and now we need to find out our FC. So from this expression, what is your FC? FC is nothing but 705 minus 5. So once if you subtract this 705 minus 5, nothing but 700 kilohertz. So the carrier signal frequency is 700 kilohertz. So just remember one thing, the highest frequency component. What are the frequency components that present modulated? So that will modulation in our signal carrier frequency, the upper frequency, low signal frequency, so they are given the highest frequency that is and the best from we can easily know the carrier signal frequency. The carrier frequency kilohertz. Okay. Next, we have another interesting problem here. Just consider an example. An AM modulator has output. An AM modulator has an output x of t equal to a into cos of 400 pi t plus b into cos of 380 pi t plus b into cos of 420 pi t. Okay, in this they have given a question. A into cos of 400 pi t plus b into cos of 380 pi t plus b into cos of 420 pi t. They have given an expression. The carrier power is 100 watts. They have given the carrier power. The carrier power which is equal to 100 watts and the efficiency is 40%. And the efficiency of your AM signal, the efficiency of your AM is 40%. Now, find the values of A and B. Now we need to find the values of A and B. So in order to find the values of your A and B, so in order to find these values of your A and B, so first given the carrier power is 100 watts. So what you all know the carrier power? So PC will be equal to A square by 2. PC will be equal to, you all know, PC. PC nothing but A square by 2. So in the question they have given the carrier power is 100 watts. Okay. So once if we equate this, we can find the value of your A, isn't it? So from here, we can find the value of your A. And next, we can find the value of your A. Next, in the question they have given efficiency. So efficiency is 40%. 40% means 40 by 100, nothing but 0.4. You know what is your efficiency. Efficiency of your AM can be given as power